devastating events.
And yeah, I think that's a very valuable comment and also a good moment to segue into starting our webinar. So if I may ask all the other panelists and turn their videos off, except for Paulo, the president of Paulo Lourenço, professor in Portugal, Minho, and president of ISCARSAH. Paulo, let's get us started.
Okay, so good morning or good afternoon, good evening to all of you. Where are you joining from? Well, it's a pleasure to introduce this webinar. You probably know that ISCARSAH is close to 200 members now from close to 60 countries. And we have a new bureau that started the job in the summer. And so one of the initiatives that we are wanting to somehow further develop is these webinars that were popular in the past. It's a very good way of course, joining the community and sharing experience across the globe. And so I thank a lot, of course, team for organizing this, and Steve also for being moderator, and our participants. We are all aware that earthquakes are the most killing natural disaster. It's also the one that destroys most of our built heritage, and a lot of the cultural heritage buildings are in fact very vulnerable. And so even though we keep on seeing the results of earthquakes across the world with severe losses in our built cultural heritage, somehow our societies fail to recognize this. I think there's much to learn, and I really thank the speakers and team and Steve for organizing this. So enjoy the seminar. Thank you very much.
Thank you very much, Paulo. So my name is Tim Michiels, and I'm a structural engineer at Old Structures Engineering in New York and a professor at Columbia University. Moderating this webinar with me is Steve Kelly, the past Secretary General of ISCARSAH. Steve is a conservation architect and engineer based in Chicago who has been involved in several post-earthquake campaigns, including in this one in Turkey. And today's webinar is brought to you by ICOMOS ISCARSAH. Or for those who don't know, the International Scientific Committee on the Analysis and Restoration of Structures of Architectural Heritage. And as more people join our webinar, I will very briefly for 2 minutes introduce our scientific committee. So what are we? We are an international group of engineers, architects, scientists, and educators dedicated to the restoration and care of built heritage. We mostly focus on the structural and technical aspects of conservation and architectural heritage. We have a new board, as Paulo said, since 2023. Our president is Paulo Lourenço, and behind the scenes today working hard is our Secretary General, Tom Morrison. The goals of ISCARSAH are, amongst others, to disseminate knowledge, promote international cooperation, and organize international training programs. Another goal is to collaborate with other scientific committees. And we are very happy to welcome members from a wide variety of ICOMOS committees attending today, and we look forward to their inputs. In the past years, ISCARSAH has published principles for the analysis, conservation, and structural restoration of architectural heritage. And we are currently finalizing the monumental task of creating updated guidelines for the analysis and restoration of heritage structures. We publish a newsletter, we publish a new bulletin, we organize 2 webinars each year, and all of this information and documentation can be found on our website and on our YouTube channel. We also organize international workshops. The latest ones were in Iran, Korea, and Japan, and the next one will be held in Romania next year. And before handing over things to Steve, I want to draw your attention very quickly to this new publication by ICOMOS Japan, came out in the last month. And this publication describes the lessons learned from seismic events on heritage structures in Japan. I believe that, especially with the webinar we have programmed here, it is something of relevance to almost everyone. It is free to download, and we will provide a link to the document in the chat. Then finally, our following webinar will be organized around March, and we will present and celebrate the new ISCARSAH guidelines. A team of ISCARSAH experts has been really working extremely hard for several years under the guidance of Perry Rocca to get these ISCARSAH guidelines ready. They're almost ready to go. So we will be discussing them around March. Finally, I want to acknowledge that this webinar was made possible by several people, including Steve Kelly, Meltem Vatan, Tom Morrison, and Ahmed Tourer. You can reach us at iscarsah@gmail.com, follow us on Facebook, or find our website. Steve, over to you.
You're muted, Steve.
Okay. Modern state of Turkey is one of the most archaeologically and culturally rich places in the world. It has 15 sites on UNESCO's World Heritage List and 60 sites on the tentative list. About 11,000 are officially registered with the Turkish government. In addition to the tragic loss of life, its threatened treasures are one of the reasons that our community is focused on this disaster. On February 6, 2023, a 7.8 moment magnitude intensity earthquake with an epicenter near Gaziantep, that's here, struck southern central Turkey and northwestern Syria. The greatest intensity was felt near the epicenter and in Antakya, which is down in this region here. It was followed 9 hours later by a 7.5 MMI earthquake, which was 95 kilometers north of the initial earthquake, which is right up here. The most momentous aftershock of 6.4 MMI occurred in Hatay province down here on February 20th. That collapsed many buildings that had already been weakened by the previous earthquakes. The confirmed death toll is more than 50,000 in Turkey and 8,500 in Syria. It is estimated that 160,000 buildings were destroyed. The earthquake area lies close to the complex triple junction between the Africa tectonic plate, the Arabian plate, and the southwestern edge of the Eastern Anatolian plate. So this is the Arabian plate moving this way, the Anatolian plate, which wants to move that way, and the Africa plate, which is moving this way. This is the earthquake region, and to pay close attention to these tectonic plate boundaries, because here's that same area. This is a classic tectonic boundary plate earthquake. There were thousands of aftershocks. The largest number of casualties and greatest physical damage was in Hatay province and near Antakya down here. Let's look briefly at Antakya and Hatay province, as it is indicative of the rich heritage that one could possibly find throughout the earthquake area. The Hittites settled here in the 17th century BCE, followed by the Persians in the 6th century BCE. The city of Antioch was formally established around 300 BCE, and it grew into one of the three capitals of the Roman Empire, following Rome and Alexandria. During this time, the word Christian was coined in Antioch, so I think that everybody's heard of Antioch. It's interesting to note that Antioch has had numerous devastating earthquakes. The one in 526 AD is estimated that between 250,000 and 300,000 people were killed. There was also an earthquake in the Anatolia, Syria, Aleppo area in 1138, which reoccurred in 1156. And more recently, there was an Aleppo earthquake where the death toll was estimated between 30,000 and 60,000 people. So this is not just a one-off occurrence. And I'm sure that this kind of stuff has happened throughout Turkey in its in its history. The 70% of the buildings were destroyed. What's interesting to note in it, this is Antakya. It has a river going through it. This is all an alluvial plain. This is the new city, and this is the historic city. 70% of the buildings have been destroyed, and this photograph was this Google Earth image was taken in April, and so more of these buildings have been destroyed. This is almost completely cleared out at this particular point. When we were there in June, they were still reaching their way to the old part of the city. And you can see that these points, or these were the areas that we were actually visiting. It's in an alluvial plain, so there was a lot of damage here. But to the east, where there's a mountain, everything that was up on the mountain, it did okay. And it's kind of interesting that that's how earthquakes occur, that normally in soft soils there's more damage. These are the 3 buildings that we decided to focus on during our project there. One is the more humble Ahmadiyya Mosque, which was constructed in 1842. This is the interior photograph of that. This is the St. Paul Greek Orthodox Church, which is the seat of the Antiochian Greek Orthodox Patriarchate. And then there's the Antakya Synagogue, which was built in 1890 to 1900. These buildings are not really that old, but for instance, the Antakya Synagogue, there has been a Jewish congregation continuously in Antakya for 2,500 years. And I'm going to leave these recommended conservation technologies that are in keeping with the ISCARSAH principles that was developed by our next speaker, Emre, in collaboration with Umut Almak and myself. You can carefully review this list when this webinar will be uploaded onto our YouTube channel, which will happen very, very quickly. And so without further ado, I would like to introduce our first speaker, Emre Kichali, who is an assistant professor in the Department of Architecture in Kocaeli University. The primary research areas lie at the intersection of architecture and engineering, with a specific focus on conservation. The studies encompass various topics, including architectural heritage and sustainability, the consolidation and strengthening of historic buildings, thermal performance, non-destructive testing in buildings, and planned conservation. Emre is an active member of organizations such as ICOMOS in ISCARSAH, Turkey, the Cultural Heritage Preservation Association, and the National Wood Association. Emre, go ahead and share your screen, and let's go.
Okay. Thank you for the nice introduction, Steve. And I'm so glad that you invited me to this webinar as a speaker. I plan to say a few words about the earthquake and data belong to Turkish experiences. Then I will present some monuments and civil architecture examples which experienced the devastating earthquakes in February, damage mechanisms, and the importance of historical sites after the earthquake in terms of social resilience. As you said, Steve, a moment magnitude 7.7 and some sources is 7.8. Earthquake occurred in the East Anatolian Fault, Turkey, on February 6th at the local time 4:17. The earthquake's epicenter was located in Pazarcık, Kahramanmaraş, and the focal depth was reported as 8.6. Approximately 9 hours later, there was another earthquake. It was around 1:24 p.m., a major aftershock, 7.6, sometimes 7.7 some sources. Epicenter in Ekinözü, Maraş. And then on February 2023, another triggered earthquake with a magnitude of 6.4. The earthquake caused severe loss of life and heavy damages in 11 cities and provinces. Strong motion stations show that the maximum peak ground acceleration was reported as 1.23 G during the first earthquake at Antakya, and during the second earthquake shaking, the maximum PGA was reported as 0.65 in Kahramanmaraş, Göksu. Let's turn to the next issue, historical earthquakes in the whole region. Along the East Anatolian fault zone, previously documented strong events include 1939 Erzincan, 7.9 magnitudes, and until 2020, Doğan Sea Bridge earthquake, strong motions were observed. And it's really significant that the devastating earthquake was expected in the south part of the East Anatolian fault zone. Rescue of life from the collapsed heavy damaged buildings is the priority, and damage assessment along with the security were executed after the rescues. And it was determined that 35,000 buildings collapsed, 17,000 buildings should be demolished urgently, and approximately 180,000 buildings were severely damaged. These data was taken from the Ministry of Environment, Urbanization and Climate Change of Turkey. And the statistics were done until the 6th of March, so it's just 1 month data, let's say. According to results of the damage assessment, again from the same ministry, 520 approximately 100,000 houses were determined as requiring urgent demolition, collapsed, and severely damaged. When we come to the cultural assets in earthquake-affected provinces, there are approximately 8,500 cultural property in the region, and approximately 3,000 cultural property were assessed until the 25th of February. And according to that data, 169 were destroyed and 535 were severely damaged. After summarizing the earthquakes and their damages to the region, I would like to talk about the experiences in the region which I gained. It has 3 parts with different projects and initiatives. First one is the collaboration of General Directorate of Foundation and ICOMOS Turkey. We did some damage assessments in the site of the cultural assets which belong to the directorate. I was in Adıyaman and Urfa after the 10th day of the earthquake. Esra Balcı will explain the details of this experience in her presentation. The second one, actually, Steve explained a bit the project. It was the site visit to Antakya and the parts of Samandağ with the World Monument Funds supported by the Association for the Protection of Cultural Heritage. And the third project provided me to visit Adana and Adıyaman, the whole provinces, to do the damage assessment of cultural properties. The project also covers Maraş. I am sure Esra also will talk about it. The project was funded by Heritage Management and supported again by the association. Different assessment firms used for the structure, and it's really important to have the assessment firms in the area, and we realize that. On 16 February 23, 10th day after the earthquake, we visited 14 buildings in Adıyaman to assess the damage level with the team from the directorate. In the city center, partial collapse of load-bearing walls, domes, minarets, and the critical cracks were observed. Here, we use Copernicus European microseismic scale classes, and they have 5 different classes, but at site we combined very heavy damage and the collapse together. So as you can see, first refers to the green colored no damage, yellow is slight structural damage, orange one is the moderate, and the red for a very heavy damage and collapse. We have 11 heavy damaged buildings, 1 moderate damage, and 1 slightly damaged buildings in Adıyaman. Here, the city center of Adıyaman, before and after the earthquake, a lot of buildings were collapsed, as you can see. I'm going to give some general overview of damages, mechanisms, and other issue regarding to the social resilience and the historical environment. This is Grand Mosque. The mosque dated back to the 16th century. The mosque was built in the latest form in 1863. Later, the mosque underwent repairs and restoration in the year of 1902 and 1986. The mosque collapsed after the first earthquake in the morning. The structure next to the mosque, the reinforced concrete next to the mosque, was demolished over the architectural heritage during the second earthquake. So the rubbles were mixed when we arrived at. After the earthquake, the west and the north walls are standing, and the soil conditions and the interventions should be analyzed thoroughly for the restoration of this structure. In the standing walls, there are diagonal cracks. Out-of-plane mechanisms occurred in the structure. There was no box effect, and the stitching and tensioning rebar elements are observed in the west elevation. When I visited the area in September 2023, there was this timber framework supporting the structure. You can see some part. And also here we have these rubbles from the reinforced concrete and also the original materials. They are mixed at the site. Another mosque is Adıyaman Kap Mosque, constructed in 1768, renewed in 1923. Out-of-plane mechanism has occurred on the east and the south wall. Minaret and the portico were collapsed. Building materials and stones have fallen onto the street. Partial collapse is also present in the lower sections of the facades. The timber bands, as you can see here on the south facade, they are not continuous. But on the other hand, there were no structural cracks on the dome. During the restoration of 1923, the dome structure changed into a timber dome. It's light. The connection of the cover and the vertical load-bearing elements should be consolidated, but it performed very well. When I visited again, I can see also these supporting elements in the covering of the portico. Another building was the Metropolitanate of Adıyaman Syriac Church, which is located in Adıyaman. The structure constructed in 1883, restored in 1905, 1953, and 2000. The east wall has partially collapsed. Stones falling onto the wooden altar have caused damage to the cultural property. In the arched wall of the last portico, let's say here, we can see some vertical separations, cracks, and falling stones were observed. The columns inside the structure are connected to the wall with the tension bars, so they present a really nice horizontal diaphragm, and there's this these elements prevented a potential collapse in the interior spaces. The other issue that I would like to talk about the social resilience. As you know, the resilience is have the ability to absorb, recover, and prepare for future shocks. And these resilience concept promote sustainable development. And the earthquake showed that the importance of the conservation of cultural heritage, because the citizens and the communities are active in the downtown. The survivors would like to see the monuments, and they would like to be in the downtown. Although the landmarks, especially the Grand Mosque of Adıyaman, were collapsed, the citizens were flowing here. This bakery was giving free breads, and there was this huge queue. The tea house was a social hub for the community. The hammam structure in Birecik was used for cleaning, and the mosques were using shelters for the people who lost their houses. The second visit was to Antakya, as I mentioned. And in Hatay, where the earthquake caused the most damage, approximately 215 housing suffered in the severe damage and the collapse. The city center of Hatay and the surrounding districts were particularly affected due to the alluvial layer brought by the Asi River, which increased the intensity of the earthquake waves. In these areas, Hatay was the most affected province by the earthquake. Hatay State Parliament building collapsed. Latin Catholic Church in Iskenderun suffered severe damage. Grand Mosque, Habibi Neccar, Sarimiye Mosque, Greek Orthodox Church, they are the historical religious structures which collapsed. Some hospitals were also collapsed. Police station and disaster and emergency management authority building in the region collapsed. In the video, you are watching the south part of the Kurtuluş Avenue, where historical structures are located, and they suffered severe damage, as you can see. In Antakya, June 2023, we visited the historical city. These are like St. Paul Greek Orthodox Church, Grand Mosque, Habibi Neccar, Ahmediye Mosque. Also the commercial areas, Uzun Bazar, various stores, Kurşunlu Han. some educational buildings, administrative structures, Kurtuluş Street, which is shown in this red line, the synagogue, traditional houses, archaeological sites, and also the villages and Vakıflı, Batayaz, and Yoğunluk. I would like to show you some images that I took from the project. This is Ulu Mosque. In June 23, picture was located in the right part, and before the earthquake is shown in the left part. It was restored, actually renewed in 1872 earthquake, which Steve said that Amit earthquake, originally Memlük building during the Ottoman era, but when we reached there, it was all devastated. There's a full of rubbles, and there was no any evidence about architectural property and structural property of the structure. The second one is the Greek Orthodox Church. There was a timber church, and it was destroyed during the Amit earthquake, 1872. Then in its place, the current version of the structure was built in masonry at the end of the 19th century. The structural system is stone masonry walls with ashlar on both leaves, and the core composed with the rubble stone and mortar. The church has been severely damaged, as you can see, due to the earthquakes. The covering of the structure has been lost. The upper parts of the walls are missing here, as you can see. They have white cracks, discontinuities. The stones are scattered, and iron clamps could be observed. The tie rods also were seen in the rubble. Some were broken. This image belongs to Umut Almaç, and he had this detailed picture, and I would like to mention his name here. Also, we visited the villages, and this is a very interesting one. In the Yoğunluk, we saw this unfinished church, a small, I'm sorry, it's like a Batayaz. So here there's this unfinished three-aisled church, and this structure showed no cracks, and it was all standing without any damages. Considering the social resilience and hope from the community in this devastated city in Antakya, the bazaar was partially active. Commercial activities were all started, and people would like to spend time there. The rubbles of Mahremiye Mosque inside the Uzun Bazaar, you can see here, can be visible in this picture. We had some lunch, and we just bought something from the people, and actually they don't want any payments from us. It was really interesting and very touchy. On the left picture, you can see this antique shop. The owner was there playing a "Wish You Were Here" song from Pink Floyd, and they were really stubborn. They didn't leave anywhere, and they were just trying to keep the structure and would like to be there in the downtown. And from the third project, I would like to show you some perspectives. This is a very interesting case. We are in now Eski Kahta in Adıyaman, Yenikale maybe. A massive rock located at the top of the mountain in the neighborhood Eski Kahta in Adıyaman split in the half during the aftershocks. You can see this split version of the crack and the rock and the map here. Some of the rocks detached from the mountain reached the middle of the village. In the picture, you can see the splitted rock, and some buildings were collapsed. I have not worked on the reason why these buildings collapsed surrounding buildings, but the rocks coming from the mountain was one of the reasons for the damages. And also you can see the castle fortress from this perspective. Another one is in Damlacık, which is located in Adıyaman too. We visited in September. This building was constructed in 1990, so the only damaged part is the cover of the entrance for the barn here. It's promising to see the traditional technique in the area and observe that it resisted the seismic loads of these devastating earthquakes. The lady, the owner of the house, stated that there is no damage in the main building, only the cover. As you can see, the traces of the timber beams on masonry walls were collapsed. This part, the only damaged part for the structure. And it was really nice to see the traditional techniques which were used in 1990 and standing without any damages, especially the places where the people live. So when I come to the final remarks, it's essential to remember that vernacular settlements and techniques, timber is a key factor in the construction system, and for the traditional strengthening too. Strengthening methods should be planned with merging of traditional and contemporary approaches together. Preserving the original material elements of architectural heritage is necessary. The authentic material, the original materials could be lost, and sometimes it could be mixed with the other structural rubbles, as we saw in the Adıyaman Grand Mosque. Historical surroundings and the cultural heritage are very important key factors in social resilience. Historical mosques, complexes like hammam structure, those with minor damage or undamaged one, have been used as a temporary shelters for the public after these earthquakes. There are really great potential to work scientifically in the area. Each structure has its own peculiarities. It's necessary to remember caso per caso, like a case-by-case motto. So it's very important to reveal the lessons learned from those earthquakes, and each structure would have some stories to tell us. These pictures were captured in Saimbeyli, Adana, which is close to actually the first earthquake epicenter. The structure, for example, this barn structure and these abandoned obsolete structures resisted the seismic loads in a very healthy way, and we can use, and we always remember the timber is a really good material when we talk about the earthquake. So I would like to say thank you and give the floor to the next speaker, Esra.
Okay, as our next speaker loads up her talk, I wanted to remind everybody that's on this webinar this morning that if you have any questions, please use our question and answer function and put your questions there. Our next speaker is Ezra Ekşi Balci, who is a PhD candidate working on her dissertation about rural landscapes and the dynamics about their changes. She is a conservation architect with 2 MA degrees from Istanbul Technical University and Mimar Sinan Fine Arts University. As an ICOMOS Turkey member, she has taken part in architectural conservation projects of castles, mosques, traditional house buildings, historical sites, training and awareness raising projects about tangible and intangible cultural heritage. After the February 2023 earthquakes, she has been to the region many times for humanitarian help and damage assessment of cultural heritage buildings. So Ezra, take it away.
Thank you. Hello, everyone. I wish you all a nice day and a fruitful meeting. Thank you very much for the organization of this meeting and for inviting me to share my experiences. I have been to the earthquake region for many times. As you see the details here, 10 days after the earthquake to Gaziantep, and from the beginning of April to the 18th of April to Defne, and at the end of July to Kahramanmaraş, and in mid-September in Adıyaman. I took part in the assessment of earthquake damages to cultural assets in all, but the second one to Defne is out of this list. I'm currently working in İzmit municipality. In Defne, I was in charge of the social center opened by İzmit municipality in Harbiye neighborhood. For this, I would like to thank İzmit municipality and my colleagues there and our mayor, Mrs. Fatma Kaplan Hürriyet, making my all kind of work possible in the region. Today, I will try to make a presentation with the impressions I have collected during my visits to the earthquake region. On the morning, 6th of February, ICOMOS Turkey communicated with each other with great sadness and amazement. We tried to reach our members in the earthquake region and learn about them and their families' situation. Working with cultural assets in disaster times is a special area of expertise, as we all know. In this field, Zeynep Gülünal, who was also the vice president of ICOMOS International at that time, is a worldwide expert. He was in the field from the zero moment of the earthquake earthquake, and we were able to hear from her through ICOMOS Turkey President Burçin Altınsay and members of the National Committee. As ICOMOS Turkey, we made a call for volunteers to take part in earthquake studies. About 50 experts responded to this call, and our aim was to provide support to the public, civil society, and individuals on the expertise that cultural assets will need after the earthquake. As a matter of fact, after 8 days from the earthquake, the General Directorate of Vakıfs of the Ministry of Culture and Tourism made a call. The call about taking part in damage assessments of Vakıf buildings reached ICOMOS Turkey. ICOMOS Turkey shared this call with the volunteer group formed in the first days of the earthquake. Together with 7 experts, I responded to this call and participated the field work. Who were these people? Me in Gaziantep, who were these 7 experts, and Nisa was in Kahramanmaraş, and Süheyla was in Adana. Ahmet Türer, as you all know, was in Malatya and Elazığ, and Erkan Kambek was in Antakya. Umut Almaç was in Diyarbakır, and Emre Kisalı was in Adıyaman and Şanlıurfa, as he recently shared. I met with the team from the General Directorate of Foundations who came from Ankara to provide support to the local experts, as well as expert colleagues from the Gaziantep Regional Directorate on the morning of February 16th at 11 o'clock. I participated in the assessments in Şahin Bey district, which includes the historical center of Gaziantep. On the morning of February 17, after visiting 3 structures in Şahin Bey district again, I have been to Şehit Kamil, Nurdağı, and İslahiye districts. While the center of Gaziantep is relatively far from the main fault line, the İslahiye and Nurdağı districts are located right next to this fault line and have been significantly more affected by the earthquake compared to the center of Gaziantep. We had a list that included a total of 87 Vakıf buildings for Gaziantep and its districts. Due to time constraints, we worked in groups and I was able to see 23 buildings. You can see the distribution of the buildings according to their functions and damage level on the screen. Out of the 23 buildings, 5 were undamaged, 6 were slightly damaged, 9 had moderate damage, and 3 were heavily damaged. The overall damage levels throughout the province were also concentrated at slightly and moderate damage levels. These damage conditions actually give us an idea about the structures in which community members can take shelter after the earthquake at the neighborhood scale. I would like to convey the general impression I obtained during the preliminary assessment work, as I will provide the details of the buildings within the framework of these impressions. I realized that a particular issue is of great importance: locality and local knowledge. In this study, I encountered locality in 2 dimensions: the institutional dimension and the user dimension. By the institutional dimension, what do I mean? Colleagues from the Gaziantep Regional Directorate still carrying the effects of that major earthquake, and just after 9 days after it, they participated in the assessment work, leaving their families alone for a significant portion of the day. If it weren't for them, these damaged structures might not have been identified with such detail in that speed. Their presence allowed us to easily reach the buildings within the city, obtain first-hand information about the buildings, including their age, past repairs, or existing projects, and establish rapid communication with the local users. How did the local users contribute to this work? Apart from 3 or 4 modes and the public bath, we were able to enter all the buildings. When we entered the mosque courtyard for assessment, the staff or local community members immediately surrounded us. Once they understood that we were from the General Directorate of Vakıfs, they started showing us the locations of newly formed damages. We, as professionals, can determine whether a crack or separation on the surface of a stone is new or old based on its brightness. But sometimes light can be misleading. In those cases, local people easily showed us which damages were new and which had been there for a long time. This thing happening had an impact on me because I had always seen it as a field of expertise in my professional life. Of course, every building has a story and the users are the ones who know it best. But honestly, I had never thought that one day I would be doing damage assessments together with these users. And another thing, during the initial days of the earthquake, local communities sought refuge in the courtyards of mosques and used the physical facilities of the mosque to meet their cleaning and toilet needs. These spaces, which initially served as emergency shelters for basic human needs, later transformed, and later in 3 or 4 days, transformed into places of worship again, gathering, sharing sorrows, and collectively mourning the tragedy. For example, the Dervish Pasha Mosque we saw in Islahiye was heavily damaged and inaccessible. But people were praying peacefully in the courtyard while numerous debris removal efforts were taking place around. When I returned from the field and saw what happened in the courtyard of a temple after the Nepal earthquake in one of ICORP sources, I realized that I had witnessed something similar in Islahiye Dervish Pasha Mosque courtyard. I grouped the structures I saw based on their damage levels for Gaziantep. The Tabak public bath had not suffered any damage, but its restoration had just been completed shortly before the earthquake, and the water supply had not been connected yet. After 5 or 6 days being unable to enter their homes, people were in need of bathing facilities outside their homes. The public bathkeeper seen in the photo on the left was feeling well to have the building undamaged, but also feeling upset because the bath couldn't serve the public when it was most needed. And the Buğday Hand and Tahmis coffee shop, located in the historical bazaar of the city, were opened without any damage after 9 days from the earthquake, and started serving customers. Seeing both of them intact and functioning was a good reason to be hopeful, not only to us as external experts, but also to the local communities, I guess. And for slightly damaged buildings, for the most, you can see the cracks on the walls of most, and I won't go in detail as we don't have much time here. And the house, the Emine Güliz Vakıf House, damages were identified with the help of the user again. The stone rows of the openings had shifted by 3 or 2 centimeters. The chimney of the building has collapsed in the middle of the street in front of the house. The user had moved the chimney stone pieces to the side of the street, and upon our recommendations, he relocated the pieces to the courtyard of the building. Earlier, 2 slides ago, I shared Sheikh Fethullah public bath among the undamaged structures. Unfortunately, the Sheikh Fethullah Mosque, facing the same square, had suffered moderate damage level because of the earthquake. The stone blocks on the inner walls of the portico had collapsed. The top point of the minaret had fallen onto the minaret balcony. The cracks were visible on the interior and exterior main walls and semi-domes forming the roof system. Unlike the mosque, the castle located below ground level had not been damaged in the earthquake and continued to flow its water in a peaceful and serene manner. The stone blocks you see here had fallen from the main walls of the mosque. In the early days of the earthquake, tents were set up in the square surrounding the mosque, and the local residents have moved these stone blocks to stabilize the tents. When we saw those stones in front of the door of the courtyard of the mosque during our assessment, we asked what they were, and the imam, the official of the mosque, told us the story. At that moment, when we were there, they were returning the stones to the courtyard of the mosque as the tents were removing. And two examples from heavily damaged buildings. It is common in the earthquake zone that the minarets collapse completely or partially, damaging the main spaces of the mosque. Kanalıcı Mosque is one of these examples. Upper part of the balcony minaret fall into the courtyard on the roof of the main hall and to the women's gallery. While we were conducting the assessments, there were requests from the local residents for the removal of the minaret as they were afraid of the aftershocks, and the building was in a very busy urban area. The collapse of the minaret onto the wooden roof didn't damage the load-bearing elements, but broke through the wooden coverings and reached the flooring of the women's gallery, as we can see here. My last example is from Gaziantep, is the Derviş Paşa Mosque that I mentioned earlier in the slides. I obtained a photo of the minaret's condition before the earthquake. Here you can see it. And here the minaret falls onto the roof of the mosque from the point where the material and masonry pattern change. If the minaret had not been obstructed by the adjacent reinforced concrete building here, and could swing freely, it would maybe not have collapsed. While the southern section of the prayer area completely collapsed, the internal walls and outer main walls remained standing quite robustly in their direction, in other directions. And in this slide, this is Defne and Antakya, where I have been for humanitarian aid in April. What I want to show here are the things about the time I was in Defne, as I say. And it is more about the intangible side of cultural assets. It was interesting to see how people are cooking and eating and also calling you to eat the traditional food in that under that conditions, under that disaster conditions, because people whose houses were damaged, they carried to the tent city the food they had prepared in summer to consume in winter. So they keep cooking their traditional food and also cooking it for the visitors. It was important for them to ensure this continuity, as I guess. And there are still, of course, 3 tombs of the prophet Hızır in Defne, and these had been gathering places since the first day of the earthquake. During my stay there, I came across two special days they celebrate. When in these days, the local people cook and distribute a dish called, yani şehir, dish called krisi or ashure. Before one special day, I told the manager of the kitchen run by the military service to cook less food the other day because they were going to cook, the locals were going to cook the hurisi. However, they didn't want to risk it because maybe they won't cook. So they cooked for 6,000 people, as they every day do. And half of the food was left for the next meal. And the manager told me that I was right to offer to cook less. Umut here, not Umut Almaç, Umut here, one of the residents of the tent city, come one day and said that he wanted to take us around Antakya, and he took us to St. Pierre Church and Habibi Neccar Mosque and the mountain. He took around us the museum, and he told us stories about the city. He was feeling good to show us the cultural assets of his city, even in that difficult time. We once again understood what the undamaged, intact cultural assets mean for the people of a city after such a disaster. And I have been in Adıyaman and Kahramanmaraş within the scope of the damage assessment project carried out by the Heritage Management Organization from Greece and the Association for the Protection of Cultural Heritage from Turkey, with the support of the Alif Foundation. In this study, we mostly looked at the monuments and residential buildings in rural areas and residential buildings in the urban fabric. This study will also be reported and shared with both the Ministry of Culture, which is also a stakeholder of the project, and the national and international public. Bağpınar in Adıyaman was one of the first places we saw in Adıyaman. It is a village connected to the center. It is right on the shore of Atatürk Dam Lake. After the confiscation made due to the dam, a significant part of its population migrated to the center of Adıyaman. However, those who migrated kept their connections with the village. During our interview with the village muhtar, the government representative of the village, we call it muhtar, he told us that a significant number of people from the village living in Adıyaman city center had lost their lives in the earthquakes. He also said that many families living in the center had migrated back to the village after the earthquake. He said that although schools opened in September 2023, there are still people who commute from the village to their jobs in the center. There were 2 fountains in the village, one for women and one for men. The men's fountain had lost most of its water, but the women's fountain on the right here, you say, still had a high flow rate at certain times of the year, depending on the rainfall regime. According to the muhtar, this fountain in the village was used intensively as an alternative to clean water infrastructure that collapsed in Adıyaman immediately after the earthquake. And people come here from the city to fill up their water tanks. Another family we met in the village said that the houses of the people who migrated from the village to the city were destroyed. But they, the ones didn't migrate and stayed in the village, were able to create safe and warm spaces for themselves in the village settlement after the earthquake, even though their buildings were damaged to some extent. In this example, it is possible to see the role of rural traditional historical settlements in times of such disasters. I think it is important to keep these areas strong, not to abandon them, not to dehumanize them, and not to lose the continuous and sustainable resources offered to them by nature. And I would like to say in this slide, say something about the impact of cultural assets on solidarity and recovery process through their post-earthquake conditions at the scale of a neighborhood. This is the intersection area of Divanlı and Turan neighborhoods in Kahramanmaraş, Dulkadiroğlu district. And there are 3 mosques you see here and the public bath in this small area. You can see their conditions before and after the earthquake in the photographs. After the earthquake, unfortunately, all of them have partially or completely collapsed. This is a very technical issue for the architects and engineers of the conservation fields. Moreover, some of these buildings have been recently repaired. However, for the people of the neighborhood, this is much more than a technical issue. In fact, the areas of the neighborhoods that we expect to be the strongest, the areas where people who will reflexively seek refuge, have become unavailable after the disaster. Therefore, the impact of cultural assets for these neighborhoods has not had a positive effect in the sense we expected. Perhaps it has increased the sense of destruction they have experienced. Keeping cultural assets strong and standing is not only about the buildings. It is also about keeping the users of these buildings and the society strong, especially in times of disasters. And I will present my last verse with an image of a fountain in the same intersection area, in the same neighborhood, Turan neighborhood from Kahramanmaraş. This fountain has survived and even continues to provide potable water, and the inhabitants feeling water from this fountain. First of all, I would like to say a few words about the cooperation between ICOMOS Turkey and the General Directorate of Foundations on the 10th day of the earthquake. Steve also mentioned the second, and also Emre mentioned the second 6.4 magnitude earthquake that occurred on February 2020 highlights the importance of initial assessments because there were buildings that didn't collapse during the initial tremors but collapsed later on. It would have been better if the geography wasn't so vast and damaged buildings could have been suspended and reinforced. Perhaps they wouldn't have been affected by the earthquake on the 20th February. In order for any lessons to be learned from the disaster to reach the sectors involved in cultural assets such as education, implementation, materials, and project planning, these collaborative efforts should be maintained continuously. And these collaborations are important not only for sharing the workload, but also for experiencing the ability of different types of institutions to work together during extraordinary situations and sharing the material and spiritual burdens of the crisis. Being aware of the unifying and healing effect of tangible and intangible cultural assets, understanding and straightening their weakness, protecting and disseminating their strengths is important. As an example of the fountains in Turan neighborhood and Bapınar village, cultural assets continue to exist and serve as long as we take care of them, repair them, try to keep them alive by understanding their reasons of existence and reinterpret them with current needs. Understanding that the tangible aspects of cultural assets, strength of their structural systems, materials, and masonry are not only about keeping them standing in disasters. Cultural assets, especially monumental buildings, are the first places where people living in the neighborhood seek refuge in times of disaster. Preparing them well for disasters will directly make a significant contribution to the recovery processes after disasters. Because people can hold on to their lives more firmly after disasters by being positively affected by the survival of these places that they are used to, that they have always seen there, that have accumulated memories of themselves and their families. So I wish that all these works we are carrying out will contribute to the improvement and restoration of our cultural assets that carry the memories of those we have lost. Thank you.
Well, thank you very much, Ezra. And thank you for mentioning the intangible heritage, particularly the foods. We ate very well in Antakya when we were there, even though we were among all this construction and ruin. Again, I'd like to remind our participants, if you have any questions, please use the question and answer function and load your questions in there so the panel can discuss those. Our next speaker, and Ellie, go ahead and load up your presentation. Our next speaker is Ellie Vinceleo, who is an emeritus professor, National Technical University of Athens. Her teaching and research focus on the seismic behavior and design of reinforced concrete and masonry structures, as well as on documentation, assessment, and rehabilitation of historical constructions. She's a member of the Central Council of the Hellenic Ministry of Culture for Ancient and Modern Monuments, and she's also an expert member of ISCARSAH. So Ellie, please go ahead and proceed.
Thank you very much, Steve. First of all, I would like to express my condolences to our Turkish colleagues for the loss of so many lives and for the devastating effects in so many provinces of the country. I would like to say that we have prepared this presentation together with my colleague, Dr. Paliraki, who was also member of the Greek team that has visited the affected area. Although we have been to several places, as you can see on the map, we focus in this presentation on Gaziantep and Antakya as roughly representative of medium for Gaziantep and very high peak ground accelerations for Antakya. before starting the presentation of the damage, of the observed damage, I would like to mention that according to data, to official data published recently, up to the year 2000, in the affected provinces, a large portion of the existing building code was made of unreinforced masonry, the red color on those pies, whereas the picture changes radically after the year 2000, where reinforced concrete frame structures are the vast majority or even the totality of the new buildings. So we have a building stock made of unreinforced masonry before the year 2000, and presumably constructed in a traditional way without following a building code or a seismic code. We don't deal in this presentation with.
Ali, sorry to jump in for a second. We see the start screen of your presentation, but you have not activated the presentation, so we don't see your changing slides.
Oh, I'm sorry, I don't know why.
No problem. I think you need to hit the presentation button.
It is. I am in the presentation button. In the presentation. I don't know why it's.
Maybe try again. Now we see the slides changing.
Okay. So I'm sorry. Let me try again. Now, can you see them? Can you see the next slide?
It's loading. Yes, I think it's fine.
Okay. Thank you. I'm sorry for this. Just to let you look at this slide showing the percentage of masonry buildings in the existing building stock up to the year 2000 and after the year 2000. I was saying then that we do not deal with major monuments of complex geometry and history, including previous damage and interventions, because specific studies are needed based on data that are obviously not available to us. And before going to the presentation of the damage, allow me to observe something. Historical centers are typically characterized by a series of buildings in a continuous system and arranged across narrow picturesque streets. But this, although it adds to the charm of the urban nuclei, it poses an additional risk to the inhabitants because we know from many recent earthquakes that escape routes may be blocked, and specialized equipment for rescue operations or for removal or rubble may be hindered by the collapse of buildings across those streets.
Ali, I'm sorry, there's still a problem. Could you maybe stop sharing quickly and share again? I think you're sharing your wrong screen.
I'm sorry. I'll try again. Share a screen. Is that okay?
Yes. Yes, now it's perfect. Thank you so much.
I'm sorry, I don't know. Anyway, so this is why we believe that pre-earthquake assessment and protection of buildings in historical centers needs to include urban planning measures. Is it okay now? Can we see my?
Yes, it's perfect. Thank you.
Okay, sorry. About the structural systems we identified in Gaziantep and in Antakya, we have buildings of 2, maximum 3 story high, made of stone masonry, which is unplastered in Gaziantep. And we can see that the stones are cut and we have very thin mortar joints. Whereas in Antakya, where plastering of walls is a rule, the masonry is rubble stone masonry. And we have typically timber floors and roofs, as we can see here. In Antakya, we have also identified another structural system. We have stone masonry in the ground floor and timber-framed masonry in the upper story. So we will come back to this system later on. We identified also a very small number of buildings made of non-fired clay blocks, adobe, in Antakya and in Islahiye as well. If we look at masonry within its thickness, we see that in general it's three-leaf masonry, rarely double-leaf, without header stones connecting the two exterior leaves. And we have in between a filling material of rather poor quality. And lime mortar or earthen mortar is used for the construction of the walls. We can see the same here in Antakya, where the collapse of the outer leaf shows that there was no connection between the exterior leaves of masonry. I would also like to say that this is not a system uniquely met in Turkey. On the contrary, it's very frequent, very common around the Mediterranean. And you can see here two pictures from houses, residential houses damaged during the Samos earthquake in 2020. We have also seen in Antakya some buildings in which the exterior leaf of masonry is made of rubble stone, whereas the interior leaf is made of timber-framed masonry. We are not in position to know how extensive is the use of this type of masonry. However, we have a similar system in the island of Lesbos, which was struck by an earthquake in 2017. And I would say that although the exterior leaf of masonry has collapsed, as we can see here, the entire building stood in its place, and so the lives of inhabitants were protected. So, talking about damage, we have the same typical damage we observe to masonry buildings after earthquakes all over the world, practically. We have the diagonal or bidiagonal cracks due to in-plane shear. And the cracks range from just the simple cracks up to disintegration of the piers. And of course, also damage due to out-of-plane actions on the vertical elements. We see here the out-of-plane tilting of a wall in Gaziantep, or out-of-plane collapse of the middle portion of a wall, which was obviously not connected to the timber roof, or we may have collapse of the exterior leaf of three-leaf masonry, or the collapse of the entire wall. A weakness we know about, and we have seen after many earthquakes in many countries, is the pronounced vulnerability of piers, especially in the corner of buildings when the openings are very close to the corner. Those piers are subjected to a combination of in and out of plane actions, whereas they experience significant changes of their vertical load during the earthquake. As a result, of course, they are severely damaged or even collapsed. And we see a similar case of a crushed corner pier in Christchurch after the 2011 earthquake. An observation we made several times in Antakya is the effect of inadequate, in our opinion, interventions using reinforced concrete. In many buildings we saw the roof, the original timber roof, was substituted by a reinforced concrete slab. The purpose of this intervention is obvious. One of the weaknesses of existing masonry buildings is the in-plane flexibility of roofs and floors, and therefore a reinforced concrete slab may provide enough stiffness to the diaphragms. However, this means that we add a significant mass at the top of the buildings. This mass is not connected properly to the vertical walls, which remain unstrengthened, as we can see in this picture. And of course, the result, unfortunately, is catastrophic. To be honest, I should say that presumably there are other buildings properly strengthened. We saw some shown by the previous presenters, buildings that obviously did not experience severe damage, and so they could not be easily detected. We see also in this building that the slab, the reinforced concrete slab, which was not connected to the walls, did not prevent the out-of-plane collapse of the latter, and afterwards the slab itself has collapsed. This is what remains of the Protestant church in Antakya. Again, there the roof was substituted by a reinforced concrete slab, and the same here. Another observation has to do with the reinforced concrete ties. For several decades, many structural engineers used to believe that a reinforced concrete tie at the top of the walls, just under the roof, may contribute to the diaphragm action of the roof. Now we know that normally this is not the case. Actually, the reinforced concrete ties can contribute to the box behavior of the structures under very concrete, if I could say, conditions. Last but not least, the effect of reinforced concrete jackets was rather detrimental in the cases we have seen in Antakya. In addition to the problems created by reinforced concrete jackets, because they change the movement of moisture within masonry, and of course the aesthetical aspects of those interventions, reinforced concrete jackets that add a significant mass, non-connected to the roof and to the floor, do not constitute the best solution for interventions to existing masonry buildings. I will spend a few minutes on the historical system we have detected in Antakya. We have seen several buildings constructed following this historical system to stand. Although they are obviously non-maintained. Of course, we do not know how many other buildings of the same structural system have collapsed, but we believe that this system should be studied and, if possible, preserved. And we know that by experience, because we have a similar system in the island of Lefkada in our country, situated in the most earthquake-prone region. And this system has sustained successfully very strong earthquakes. Similar damage to adobe buildings. I will finish in a few minutes. I think that before sentencing to death unreinforced masonry buildings, we should think of the accumulated damage due to very strong earthquakes and to a sequence of aftershocks, which in several cases were quite strong. We saw the same picture in Italy after the 2016 earthquake, where after the first earthquake in August, this is a plan of a village, Accumoli, and this is the plan of the same village after a second earthquake that followed some months later. And this picture is, I think, tells us about the effect of accumulated damage. This is my last slide. I believe that there is a need for regulatory documents, codes, or guidelines for the documentation and the upgrading and rehabilitation of old masonry buildings, either individual monuments or buildings belonging to an urban nucleus. We should try to alleviate the structural weaknesses of old masonry buildings that are well known. We should try to improve the behavior of vulnerable construction types of masonry through grouting or transverse connection of unconnected leaves, etc., to improve the connection between walls, to enhance the diaphragm action of floors and roofs by applying alternative to reinforced concrete slab techniques. And there are several techniques that can ensure this diaphragm action. Of course, to connect the diaphragms to the walls and to avoid invasive and proven inefficient interventions such as reinforced concrete jackets. Thank you very much for your attention.
Thank you very much, Ellie. That was very insightful, especially the parts about the addition of reinforced concrete at the tops of buildings. Our final speaker today is John Dumsick, who is an engineer and historic preservation specialist with the U.S. State Department, Office of Cultural Heritage, which oversees stewardship to 275 international heritage properties. John currently serves as a structural engineer to Fairfax County's Virginia Task Force 1, and has deployed domestically and internationally to aid immediately after natural hazard incidents and man-made disasters. John is also an expert member of ISCARSAH and ICORP, and participated in the development of a cultural heritage resource manual for the UN's International Search and Rescue Advisory Group with ICROM's First Aid and Resilience for Cultural Heritage in Times of Crisis. So, John, if you're ready, please go ahead and proceed.
Thank you, everyone. So thank you for that introduction, and I'm pleased to be here with all my other speakers, and similar to note that The devastation to earthquakes is a common occurrence. And on a little different subject, I'm going to be talking about rescue engineering. And as Stephen said, this is something that is was a little bit outside of my structural engineering experience, working in the private sector, and it's something that I have found very rewarding. And so, part of my presentation today is to talk about things that we see that impact the rescue of entrapped victims and individuals. But also, hopefully you'll gather some interest because we do need engineers who know about existing building behavior and common damage modes, as well as those that know how to fix Humpty when we're engaged in these rescue environments. Largely, this picture just kind of shows the engagement of a lot of different people trying to solve a very complex issue. When it is done right through rescue engineering with incorporation of many different people's experience, be that firefighters, canine specialists, heavy equipment operators, it is a very nice dance. And engineers do play a critical role. I want to remind everyone that everyone's culture is important. And this is recognized in the Hague Convention in 1954. I also want to remind people that the Hague Convention's later protocols do ask us to prepare for disasters, being natural and man-made. I want to also discuss some things that I learned recently when I had the opportunity to go to a UNESCO ITC course for disaster mitigation of urban cultural heritage in Kyoto at the Ritsumeikan University. Some of the things that I came away with is that disasters are hazards with vulnerabilities. The term natural disaster is something that we should be working our way away from because disasters can be preventable. Hazards such as natural and man-made, as well as disasters that could trigger both their own primary hazard as well as secondary hazards. So, such as earthquakes triggering tsunamis, triggering floods, and floods triggering wide-scale fires. These hazards integrated with inherent vulnerabilities enable a disaster to be formed. Certain vulnerabilities that we pick up on is definitely the building and infrastructure resilience, but also the social and cultural aspects. Financially resilience, how can they build back better, as well as how robust is their preparedness network. And then once a disaster is triggered, these have impacts to not only the sense of place or sustainability of a community, but also their livelihoods and their inherent culture, both tangible and intangible, and its value and the integrity of such. So from a rescue perspective, we receive alerts very similar to many of y'all in terms of gathering information. But some of the things that we look out for when we will be responding to an incident are the magnitude, understanding how large and how widespread this devastation is, as well as the intensity and what is the anticipated level of damage. The depth for earthquakes, as many of you all know, is very important to how its impact will be on our built environment. The shallower you are, the more impact and damage will likely be a result. The date and time are also critical from rescue perspective. So this event, it had a number of aftershocks, but at 4 o'clock in the morning, most people are going to be in their bed. So when we're talking about rescues, we're talking about going to places where multiple victims are likely present and multiple victims are likely present to be entrapped. The date is also critical. This event happened early in February with very cold temperatures. So while it may be unpleasant for the rescuers, this could impact how the victims' survivability can change. We did talk about, my previous presenters talked about the number of aftershocks. This was very seismically active for a very long time. So when we are entering or responding to a rescue site, we have to have plans in place to protect not only us, but also the victim. So our rescues might take longer if we have an extensive amount of aftershocks. There was liquefaction identified in the U.S. Geological Survey alerts, as well as the Global Disaster Alert and Coordination System through the UN. And this is information that we use to prepare as we're heading to the site. Additionally, from an engineering perspective, since the world is very diverse, we rely on the work of others, people that are from that country, as well as researchers, such as many of y'all. EERI has a World Housing Encyclopedia that they have, which they use from their research and publicize it on their website. It talks about common building construction in the country of devastation. It also talks about previous earthquake assessments that have been performed, and they provide their vulnerability rating. So this is information that we're accumulating while we're deciding what resources we need. This is a picture of Adiyaman. This is an area where Virginia Task Force 1 as well as California Task 1 combined to support USAID as USA 1. It took us a while to get to Adiyaman, and we were asked to assist with devastation of largely residential buildings. And some of the unique things that we saw, or ununique things that we saw, was that there was a lot of purely collapsed structures. This makes rescue sometimes or oftentimes very difficult, and we need to rely on various types of equipment. A lot of different types of equipment also are humans and our canines. Our canines play a critical role in helping identifying where victims can be located underneath the rubble. So the observations that we observed relating to vulnerability, specifically to Adiyaman, was the widespread use of dense building materials. Some of my presenters already talked about different types of building construction, but these dense materials, as you all are very aware, is that they relate to a tremendous amount of potential energy, as well as story forces. Most of the construction that we were looking at was mainly concrete structures. These resulted in a lot of non-ductile conditions with pancake collapses and hinge slabs. And these type of conditions we have to think about as we're delayering and the process for delayering. Are we using cranes? Are we using excavators, or are we just using heavy equipment to puncture through the slabs to get to the victims? Some of the observations that we saw with the reinforced concrete was a wide variety of deformed and non-deformed reinforcement. Commonly, there was limited large aggregate in the concretes, which led to limited mechanical bonding of the reinforcement to the concrete, and similar to nature of, if we're going to be lifting objects with cranes, how does that impact our processes? Masonry infill panels, they did, in our opinion, contribute to some of the lateral stiffness initially of these buildings. And then the concrete frames, whether they were designed to act as moment frames, were kind of forced to act in that fashion. Several soft stories, especially at the ground floor, led to partial and full pancake collapses. We didn't see very many liquefaction or global rotation in Adiyaman, but there was alerts mainly around water features that this soil condition could present itself. Some notes of interest to the rescue efforts was that the density of the building materials and the way that the building collapsed, largely with a lot of potential energy, the sites were very well confined, but they trapped a lot of heat. And so going back to understanding your environment in a rescue situation where you have very cold temperatures, I don't want to say R values, but the way that these buildings were constructed did trap a lot of heat. And so some could make an argument that it aided in victim survivability, and that still has yet to be further discussed in the international search and rescue community. The strength of the interior masonry walls, there is a lot of terracotta walls that are used inside these buildings. These created voids, a fair amount of voids in these pancake collapses. And as from a rescue perspective, we look for these voids where victims can survive. And so these are just some kind of interesting findings that could help with our next response. In Adiyaman, it is in a mining area. There was a lot of volunteers with relatable experience. So that kind of made a lot of the rescue efforts more feasible and more hands on deck. There was also a sizable amount of heavy equipment available. Some of the more senior people commented that this is probably one of the largest disasters that we've been a part of, but there was a tremendous amount of heavy equipment in Adiyaman for its use. Also, regarding language barriers, hand signals that we use here in the States was widely used in Turkey. And just with a lot of diversified people, it was nice to see that a lot of people put aside their ethical and political differences to solve a problem. And maybe I'm just getting old, but cell phone service was widely available, and that helped us with communication between English and Arabic. Thank you. So these are just some pictures of the voids. This is a rescue specialist with a camera who's able to put and try to locate victims inside of a rubble pile. You can see the use of the terracotta and other building blocks that do provide spaces for survivability. This is a good picture of basically a compaction of pancake, but there is an ability to tunnel and locate victims because from the outside it looked like a standard pancake collapse where there'd be very few voids. However, we were able to work with many different volunteers and other rescuers to be able to tunnel and locate victims. Extracting victims is the ultimate goal, and sometimes we have a high survivability and sometimes we don't, but all persons are given a respectful and method of extraction, and largely this helps with the family to provide closure. So I know I'm at 16 minutes after. I do want to allow people to have questions, but I just wanted to let people know that there is a need for engineers of experience to be on these search and rescue teams. So you need to consider your skill sets. Maybe you know common damage modes. Maybe you know how to design reinforcement or shoring or bracing. But if you look at the UNESCO's kind of disaster circle, most of our activities as engineers and architects is largely before and after these disasters. And so what I'm asking for you all, and to get the word out, that we do need to search and rescue for these victims. That is a part of this, this emergency response and first aid. In the United States, we have a well-defined urban search and rescue program, both through FEMA as well as two FEMA task forces are certified as heavy teams for INSARAG, which is UN OCHA's International Search and Rescue Advisory Group. For FEMA, largely it's asking for a professional engineering license, but there is alternatives such as architects that have knowledge of structural systems that can be waived. And INSARAG for both medium and heavy certified teams, it is required to have an engineer who has a degree in civil engineering or a similar training in rescue engineering. So I think I will leave it there and allow for questions.
Thank you so much, John, and thank you to all the other speakers. If I may ask you to turn on your videos now so we can have a panel discussion. And I would also like to welcome Meltem Vatan, who is our Turkish member on the board of ISCARSAH. Meltem is a vice president, and she was instrumental in putting this webinar together. And so I'd first like to ask Meltem to comment on how this panel came together, and in a way, how did you identify some of these speakers, and how does the collaboration in Turkey work? Like, what happens after an earthquake? How many people are working on post-earthquake disaster response, and then especially in the field of cultural heritage? And the other speakers can, of course, opine on that after Meltem.
Hello, everyone, and thank you, team, for organizing this activity. Actually, this webinar, it was very fruitful for me, and I'm sure that for everyone else. First of all, you ask about how many people. I don't know exact number, but I'm happy to say that although the damage was very severe after the earthquakes, it wasn't a single one. So that's why for our country, it was really devastating one, because it has an effect on 11 cities, basically, in a large region. But I'm happy to see, and before the earthquake also to know that actually we have a large team which includes members which are experts on cultural heritage. It includes engineers, architects, art historians. So it was a good thing for us. Just a moment, please. Just excuse me for a moment.
No worries. Maybe Emre, you can jump in as well, because I know you were very involved also partly in coordination of the response. Did you want to add something to what
No.
Great. Then maybe the next question, which is, what is the status of the restoration at present, about 8 months after the earthquake? Can maybe you, Emre, and Ezra comment on that?
Ezra, do you want to start?
No, because you already shared the numbers in your presentation, so you can go and maybe I can add something. Okay.
Okay, thank you. Actually, Antakya is a very special case. The buildings were devastated a lot, and there are some initiatives that would like to have this participative actions for having a holistic approach for the city. I'm not so sure about Antakya, but actually I was one of the scientific committee of the foundation structures in Adana and Antakya. These structures were restored, the procedure was started, the architectural survey was started immediately, and they would like to reinforce it. Actually, among the foundation structures, 280 buildings were planned to restore in coming years. And so the architectural studios and other surveying structure organizations were working on it, and it's a really huge number. But we have also non-listed structures and buildings. I don't know what happened to them, but we could also think about also the listed ones. So that's it.
Thank you, Emre. Also for the panelists, if you want to comment, please raise your hand, which would help. But let's move to the next question. Ezra, for you, I think it was Merdat who asked whether the collapsed minaret adjacent to the concrete building you showed, did you observe similar instances during your mission, or did any of your colleagues, other panelists, see other instances where mosques were damaged? Because then Sadwant kind of piggybacks on the question, like, what is this status of restoration of mosques since they serve such a culturally significant function for people coming together?
Yeah. Okay. Following the law for the protection of cultural assets in Turkey, it is impossible normally to build a concrete building so close to a minaret, so high and so close. So this is not normal. The situation before the earthquake is also not normal. And I haven't seen any other example like the one I show, and I haven't seen my colleagues sharing in their presentations or in our dialogues about their experience on the site. So I haven't seen a similar example. The mosques, yes, they are very important and they need to be restored. But as Emre mentioned, we have a lot of historic buildings that has to be restored. 2 weeks ago, in one of his presentations, Umut Almaç also said the numbers that the Minister of Culture started the work. So, and just with a simple calculation, do we have that much craftsmen to work on that sites? Do we have that much specialized architects or engineers to work on that side. So it's a very huge thing, and it has to, we have to think about it for a long time. It's a long time plan. So it's not going to finish as they were destroyed at once, unfortunately.
Great, thank you. Is there anyone else of our panelists who wants to comment on that question?
Well, the only thing that I wanted to add is that we're working on the ground in Antakya with a young architect by the name of Buse Gul, who became very emotional when we were walking through some of the devastation. It became pretty apparent that if she stays in Antakya, that the reconstruction of Antakya is going to be her lifetime project that she's going to be involved with for many, many years.
Thank you, Steve. Ellie, a question for you. So you mentioned some of the retrofitting techniques that appeared not to work well. Mike Schuler is asking if you have examples of things you saw where methods were beneficial and that did work well.
Unfortunately not. As I said, there may be buildings that were properly retrofitted before the earthquake, but all the cases we saw were buildings that were damaged, and we were able to detect what did not work. We were not able what did actually work and prevented severe damage. This was not possible, unfortunately.
Okay, thank you. And I think David Schnerch has an additional question on there. He's asking, what should designers know about current best practices? And David, I'd like to direct you to one of the documents that was just recently published by ICOMOS Japan, I think, which has very valuable information. So I posted that link in the chat, and I will do that right away again. And I think I would open this to all of our panelists, including the ISCARSAH president, Paolo Lorenzo, of course, who does a lot of work on this, and Steve. But what do you think engineers who are getting started in this field maybe should read or should know about best practices for dealing with heritage buildings in earthquake areas? I know it's a very broad question, so where to start?
May I?
Of course.
This is, let's say, a question that hurts, because in many, Paolo is smiling, because I know that in several countries, there are no courses in the curriculum. I'm talking about structural engineers, about masonry and masonry constructions. So there are some optional courses, but they are not sufficient, of course, for the engineers to really acquire the knowledge that is necessary for them to deal with existing masonry structures, and specifically to deal with heritage structures. So the number of structural engineers that are really knowledgeable, I think, is relatively limited compared to the building stock that they have to deal with. And not only buildings, there are also other structures that are very important, and they should be preserved. So what they should know, not only the basics of masonry, but also about documentation, which is a step of major significance, the documentation of the structures, and also to learn about intervention techniques that can, about traditional structural systems that prove to be efficient. We saw in some of Emre's pictures timber reinforcement in masonry. We know that it used to play the role of, let's say, if you allow, of steel in modern reinforced concrete structures. So we should know about the systems and find ways to preserve them. So, I mean,
thank you so much, Ellie. Paolo, I see you wanted to comment as well. You're muted still, so please unmute.
Thank you. Well, I agree with Ellie, of course. Sometimes I ask myself not to want to cause more trouble if we don't, you know, also need to have a step backwards. And of course, one thing is having the right knowledge. The other thing is, of course, having the economic resources. And I think the most important thing is convincing the society that this is needed. And so this is mostly where we fail. Of course, an earthquake in most cases does not strike in the same place in a close range of time. And so these kind of disasters that we saw today, we saw unfortunately across the world, but there's very little will on societies to change this. And so unless we convinced, I'm not sure if the governments, if we convince the insurance companies, and of course the risk is taken into consideration at all levels, partly governmental funded, partly private funded, it will be very, very difficult to reduce, I think, seismic vulnerability.
Thanks so much, Paolo. I lost my Zoom window for 1 second. Steve, you had your hand up. Did you want to comment as well?
Yes, thank you. Both of those comments were really great, and I agree with both of them. I think that there's a need for people who get involved in these, engineers and architects, that they understand these traditional building techniques, not that they recreate them, but at least to understand why they have they've met with some success. One of the photographs that Emmerich shared in his presentation, I believe it was in the village of Damlachik, there was a stone building with horizontal wood banding, and that's a seismic culture technique that it seemed to handle pretty well. There was a big stone that had cracked right behind it, but it was and maybe the stone damaged it, but it held up from the earthquake. These buildings in this area of Turkey and in the Middle East, the first floors are usually made out of stone masonry, but the upper floors are wood frame, possibly with some filler in between, because they want to get the mass low on the building, and that's another great technique. And as Ellie pointed out, in some of these buildings in Antakya, they added concrete to upper floors. Of course, what you're doing is you're moving the mass back up to the top, and in an earthquake, that's devastating. And we've seen that in that was rampant in Haiti. We saw a lot of that in the Philippines. I'm not a person who thinks that concrete is a bad material. It's got its uses, but it's not a good material to put in an upper floor of an older building in an earthquake area, because you're changing the whole mass equation. And if we understand traditional building techniques, we start to understand that. So thank you.
Thank you, Steve. I think we have about 5 more minutes. So I just wanted to see if any of the panelists wanted to make any general comments or observations before I move to some of the later questions. So yes, John, go ahead.
you are muted.
Thank you very much. Yeah, no, I kind of echo Steve's comment in the rescue circles, and I'm sure that in the people that are not in the conservation of historic buildings, but unreinforced masonry gets a very bad rep for seismic resilience. But so does concrete, especially when it's non-ductile. And one of the I'm not going to say benefits, but I would say that typically we have more voids in unreinforced masonry buildings after an earthquake. So sometimes one could argue that there's an increased level of survivability. Not saying that having a house that collapses partially is a good thing, but I think that more study needs to be done on that. But just wide scale, URM unfortunately gets a very bad tag in it in many different circles, especially in rescue.
Thanks, John. And I wanted to pick up on the question that Aktham Al-Bakir asked in our Q&A, and he said that he believes that we must distinguish between 3 types in dealing with heritage buildings in Syria: buildings demolished due to bombing, or buildings demolished by earthquakes or by human vandalism. And I want to acknowledge here that we have titled this webinar Response to the Earthquake in Turkey and Syria, and that we've almost entirely have been talking about Turkey. This was mostly due because we had a very hard time finding speakers who were able to talk about Syria. Of course, that has to do with all of the human suffering that is going on there, which is unfathomable on several levels. And I think we need to be, as a committee, very aware of that. And if people are involved in the response in Syria, please do reach out to us and let us know how we can help and spread the word in our newsletter, in our bulletin. I am curious if any of the panelists had any involvement or any connections to the response in Syria whatsoever.
No, unfortunately not.
And I think that speaks to the tragedy of the situation there. I think we also, as we are speaking about earthquakes, need to acknowledge the other 2 major earthquakes that happened this year, the one in Morocco and the one in Afghanistan, where again, lots of human suffering was involved, lots of buildings were damaged, and it speaks to the relevance of this topic. I would like to direct all of our participants as well to a past series of webinars that we put on traditional construction and earthquakes. All of these webinars are available on YouTube, as will be this webinar once we process it. And with that, we are running our webinar for 2 hours. So I would like to thank all panelists and participants for attending. If you have questions, if you have other comments, you can write to us. You can find us on Facebook, LinkedIn, our website, or you can email us at iscarsah@gmail.com. Thank you so much, everyone.
Thank you.
Thank you.
Thank you. And sorry for my break.
No worries.